Hello. Today we're going to be looking at solving rational equations. And in this example, which the directions say solve, we really just have a proportion here. Now, they're called rational equations because they're equations that contain a rational expression. Remember, rational just means fraction. So we have some fractions here that are equal to each other. But we're really just going to use the proportion method that we've used ever since we learned it way back in junior high. So we'll cross multiply here. We have this cross multiple, 4 times 4 makes 16. And then the other one, x multiplied by x minus 6, requires us to distribute. So 16 is equal to x squared minus 6x. So we have a quadratic here now that we need to solve. Notice we have an x squared. We always solve these, or several of the methods we learned to solve these was by getting it equal to 0. So 0 equals x squared minus 6x minus 16. And then we look to factor. If we can factor this, then we'll be able to get our solutions pretty quickly. GCF is 1, and it's x times x that makes x squared. And so then what times negative 16, or what multiplies together to make negative 16 that adds to make negative 6? So a minus 8 and a plus 2. Well, this tells me that either x minus 8 is 0 or x plus 2 is 0. So x is equal to 8 or x is equal to negative 2. And let's go back and we'll check our solutions here. So if we put in if we put in 8 first, we get 4 over 8 minus 6 is equal to 8 over 4. So simplifying, 4 over 2 is equal to 8 over 4, or rather 2 equals 2. Sure is. So x would equal 8. That's one solution. Let's try the other one. If we test where x is equal to negative 2. Negative 2. So 4 over negative 2 minus 6 is equal to negative 2 over 4. So 4 over negative 8 is equal to negative 2 over 4. And so this simplifies into a negative 1/2 equals a negative 1/2, which is also true, so x must also equal negative 2. So we actually have two solutions for x that work here, and we found both of them. All right, let's look at another one. Here we have another rational equation. Notice we have 3 different fractions all multiplied together here. And so the best way to go about this is to find our least common denominator, the LCD of this. And what we're going to do is we're going to take everything times the least common denominator in order to get rid of our fractions. We'll make this easier on ourselves by getting rid of those. So our least common denominator, because this has a 5, has to contain a 5. Because this has an x, it has to contain an x. And this is a 5x, and look, we already have both 5 and x. So our least common denominator must be 5x. So I'm going to take everything, both sides, times 5x. Well, what this means is when I distribute this through, we have 3/5 times 5x plus 4 over x times 5x equals 8 over 5x times 5x. And we can look at this as 5x over 1 for each of them before we go through our canceling process. So we're multiplying together here some fractions, and we remember when we multiply we can always look to cross cancel anything on top with anything on bottom. So the 5's would cancel here. My denominator is 1 just like we wanted. We have 3 times x, which makes 3x. For the next one, 4 over x times 5x over 1. We have an x on top and bottom. Those will cancel. We're just left with 5 times 4. So it's a plus 20 equals. And then the other one, 5x on top and bottom both cancel, and all we have left is 8. And we're ready to go from there to solve. So this one's a little bit easier. We'll subtract the 20 on both sides. 3x is equal to negative 12. So x is negative 4. And let's go ahead and go through and check our answer. So we have 3/5 plus 4 over negative 4, which is equal to 8 over 5 times negative 4. Now on the left side, I can get a common denominator to make sure that these are equal, which would be a negative 20. So I'll take this side times a negative 4 on top and bottom. So that's negative 12 over 20. Well, this second piece I'll take times a 5. So we're adding on 20 over negative 20. And that should be equal to 8 over negative 20. And then on the left side, when we combine like terms, sure enough, negative 8 over 20 equals 8 over negative 20. They're the same. So this must be the correct answer. Okay, so we've done a couple examples on this. We've seen a couple more examples in class. For right now, we are done.